One person's trash is another one's treasure. I found this treadmill on the side of the road, little cardboard sign that said free, so I brought it home. I'm told these things have DC motors in them, and I've always been curious, can I take that DC motor, hook it up with a engine, and make a battery charger out of it? So that's what we're going to try to do today. This thing does not turn on. I've already tried it. The screen is completely blank. So we're starting with a broken treadmill. Let's see where it goes. Hi everybody, I'm David and I'm on a mission to take my house and garage off grid. Sometimes the solar does not recharge the battery bank and I'm looking for solutions to do that. So I'm doing some testing on some different generators right now and I thought it might be fun to try to build my own battery charger. So we're going to make a little generator, but a DC generator specifically made just for recharging the battery bank. Well, here's the treadmill. It folds up. It's just a homeowner grade. I don't know what brand it is. I don't think that's the brand for the unit, but probably just a cheap one to start with. And plugging it in, can't make it go. There's nothing on the screen. The buttons don't do anything. But hopefully the motor will be okay. I'm not sure. All right, well, taking off the cover, let's look at this motor because that's what we're after. And it says 2.5 horsepower and 130 volts DC. Well, let's take a look. Well, it still turns, so that's good. Hopefully it works for us. Before I put in a lot of effort into this thing, I want to make sure that the motor is in some kind of working state. I'm over on the workbench and I've been working on trying to get this flywheel pulley assembly off of the motor. I wanted to put a different pulley on here for V-belt. So I've been trying some tricks with powering it reverse polarity and putting some clamps on here. I can't get it off right now. It looks to me to be a threaded post on the end, and I stopped short of trying to heat it. I could heat this up to try to get it off, but you know, I think I'm just going to try leaving it on and see how it works. To help me out here, I think I want to flip this around. So the motor's flipped around along with the frame is flipped around on the vise. I now have it run over and tied in to this jump pack that I've built in a previous video. So if I close the relay, it spins and shut the relay off. Let me show that again. So here we go. And shut it off. All right. So now I'm going to try to clean this up. So that's the process. I'll keep grinding away and checking with the belt until I think it looks good. Hopefully it works out. I haven't been at this too long, but I'm realizing when I put the belt on that there is a lot more to cut away. And I'm kind of worried that by the time I cut away enough material, I'm going to so severely weaken it that it won't be strong enough anymore. So I'm going to change tactics. And that was actually yesterday, and today I went out and I got a pulley to try to put on here. Now, this is a 3-inch pulley with a 1-inch bore. I picked it up at Tractor Supply. See, the outside diameter of this is 1.5 inches, and I can't find a 1.5-inch pulley, and actually there wouldn't be material left if I was to drill this out, even if I had a bit large enough. So what I'm going to do is I'm going to try cutting away that weld mark, and then hopefully I can slip it on. It'll be a tight fit, and then I might be tack welding it to the flywheel. Anyways, let's try cutting this off and see what we can do. So let me lay out what I've got so far. I'm trying to reuse as many parts from the treadmill as possible. So we have the motor. I put it back on its original mounts with the welded pulley. And I picked up another pulley which is just 1/2 inch larger in diameter for this little tiny Predator engine. I mean, this thing is so small. It's a little 3 horsepower from Harbor Freight. It's the smallest one I think they make. And so I, just have another little V-belt pulley on there. All right, so this is the general mock-up, and let's see, I was trying to think through some tensioning options, because this is a pivot point on these original brackets. So I was thinking, maybe I just stick some blocks of wood under here or something, and as I lift it, it gets tighter. But I thought maybe I can reuse this original lineal actuator. This would lift and lower the treadmill. It would generally sit right here. But this is running on 120 volts AC, and I don't know if I could run 12 volts to it or something, but there's not going to be an electric start on this. This is manual start only, so I really don't have a reason to have a 12 volt battery out here. But it turns out the top of this, right there, has a little flathead screwdriver. So I can spin the motor with a screwdriver to tension it, so I think that'll work. I'll just ignore the wires on it altogether. So I'm going to try to hook up the lineal actuator in this spot, probably cut off these extra arms that I don't need. And I still need to mount this up higher, so I need to put some kind of bracket across here. So what I'm probably going to do is take these long rails from the treadmill, take one of these, cut it in half, and then it'll go this way. Anyways, let's get to that. All right, that's about as low as it goes until this bottoms out. So that'll be our starting point. Now it doesn't look like I need these arms. All right, little update on this project. I'm not a good welder, but the pieces of metal are stuck together, so good enough for me. Got that marked. And I've got 4 holes in the base of this plate, and looking through, this is the hardware that came with the treadmill that I took out, and I've got 4 of these bolts that I think will work pretty well. The only downside is that they just barely don't fit. Right there. Yeah, so almost. So I'm just going to take off a tiny bit right on the edge there, and then I'll have my 4 bolts. So I'm going to get the one in right here, then reposition, line everything up, mark the centers, and drill. We've got 1 bolt in, and now we can still kind of pivot. It's snug, but we can still pivot a little bit. So we've got to get these pulleys to line up with each other. And right there I can see that we're off, so we're going to turn it slightly. Right there. That looks lined up. About as close as we're going to get. This is the belt that came on the treadmill originally, and I cut it up and drilled a couple of holes in it, so that will just give a little bit of a buffer between the steel frame and the generator, hopefully. Alright, so I already put these in. Let's get these ones in place. 3 of the holes I drilled slightly larger, and this one hole I kept the original diameter. Nice. Fit in without really too much of an issue. And the nuts that I'm using came off the Treadmill as well, and they're lock nuts, or nylock. They have the little nylon gasket thing in there, which helps keep them in place, even with vibrations. So I hold the straight edge against this pulley, and then I check over here on the edge of the flywheel, because the flywheel is referenced off the edge of this pulley. And I can see I still have a bit of a gap, so I have to go in a little bit more. Okay, check it again. Getting closer. Go. Good. Now we're touching. So now I'm just a hair. I can feel it hitting right here on this edge, but we're not pushing away. But over here, I am pushing away just slightly. So what that tells me is that I'm actually cocked just slightly. So I need to tap this side. I think that's as far as we're going to get for tapping. And yeah, so it is sitting better. So let's tighten these down. So our next step is to actually get the pulley on. So what should be the case is right now we're in the fully relaxed position of this. So we should be able to get the pulley on and off, and we did. Okay, so that was actually easier than I was hoping. I was hoping it'd be a little bit more tension. But now we need to extend it to get the slack out of this. So hopefully there's enough play in the lineal actuator to get the slack out. Okay, so right there on the top of the motor, flathead screwdriver, and notice in there, you can actually see it extend. So let's try to view that. Looking good. I think I'm going to stop there for now. So if we put a straight edge across the top of the belt, and then I pull down, hope everybody can see that, I can create a gap. See that? And I was taught that you need about 1 inch, otherwise it's too tight. Now this one, I could probably go a little bit tighter because it's a brand new belt. It's going to stretch a little bit as I go, but I'm going to stop there for now. I think I'm okay. I mean, right now there's no gas, there's no oil, nothing like that, but let's just see it turn. There we go. Nice. You want to make sure that it doesn't look uneven. And I think that all looks good. I think it looks nice, ready to go. Is there a fuel shut off? So the big items are now done and taken care of. Next, we need to attach the positive and negative leads to something. These are the main components I'll be wiring into the generator. We have a charge controller. It could be any charge controller. It's just 250 volts is above the 166 volts that I was measuring open circuit voltage on the treadmill. We have a 16 amp circuit breaker. The treadmill should put out 14 amps is the maximum continuous duty, and so I got a 16 amp circuit breaker, and I've got a 125 amp circuit breaker because this is a 100 amp charge controller. And then a little choke here that I'll be wiring in to the in between the circuit breaker here and the charge controller. Hopefully all that works. This is just a little cheap DIN rail box. I didn't want any AC spikes from the brushes, so I used an inductor, and thank you to my friend Chris for helping me size that inductor. And hopefully that meant that I'm putting in very clean DC, direct current, into the charge controller. Just because there's an extra piece of steel sticking up right here. So now when I lay it down, it sits flush and it doesn't rock. So I'll secure this in place. It doesn't extend past this point. So yeah, I think that'll work. Should be enough room for the Victron charge controller and the circuit breakers. We are outside, cold winter day, but we did get a lot of production today actually. We are going to try charging this 12-volt battery. And one of the neat things about using this charge controller, I can charge 12, 24, 36, and 48 volts. So let's see what we got to do here. Let's turn on the battery. Battery's wired in, and it looks like we now can see it. Excellent. So if we click on that, we're going in and we're going to see the charge controller. So there's the charge controller. and it's showing that the battery right now is 13.27 volts. Great. So next, we're gonna get this cranked and going. Okay, so start on. All right. I could tell right off there was a lot of vibration. So I don't want this really attached to the board if it's going to have that level of vibration. But let's turn this off as well. There we go. And now we will try switching out to a different battery so that we can check that this will charge more than one type of battery. Round 2. We are going to try charging this 48 volt battery. We've currently got 53 volts. I adjusted it up to 100 amps. So if it can, it'll try to do its full 100 amps, but we'll see what it can do because we're going to peak out. This should peak out around 14 amps. So I want to make sure that we don't go over that. And this will be slowing down as we do so. Right now we're at 0. So I'm going to flip this up. You can see the engine slow down. So it doesn't look like the engine's going to be able to do this. The treadmill motor should be able to do about 1800 watts or about 14 amps continuous. But unfortunately the gas engine is bogging down when we hit about 800 watts. So I'm only halfway there or 40% there. So I really should have doubled the horsepower of this engine. Maybe a diesel engine at 3 horsepower would have had a better torque curve and I could have been able to do it. But the gasoline engine at 3 horsepower is undersized, so I can only max this out at about 800 watts. I had a lot of fun building this, and I learned a ton. So I'm sure that if I try to fix this up, version 2 will be a lot better. Please let me know in the comments below any suggestions you might have for improving this design. I had a lot of fun building it. Thank you everybody so much for watching. Please like, subscribe, comment, and share. Is there a fuel shut off?